Lesson 2, Topic Exponents Part 2, Learning Target. I can use exponent rules to simplify algebraic expressions. First off, I would like you to complete this table using your calculator. Write all decimals as fractions. Your calculator should be set up for this. If you run into any problems, please let me know. Now I would like you to look at the table and see what patterns you see. You could even, talk to your elbow partner and see if they're noticing the same patterns as you. So as you looked, I hope you noticed that when we got anything to the 0 power, we had a 1. So that's going to be something that we're going to talk about. And then as we move down the chart, we could see 8 to 4, we're dividing by 2. 4 to 2, we're dividing by 2. Kind of have that geometric sequence happening. Each time we divide by 2, and the same thing happening over here, except for we're dividing by 4. So as we get into these negative exponents, we start seeing fractions. Negative exponents, we have fractions. That's going to be another thing we're going to talk about. And then you also might have noticed that 2 to the 3rd power was 8, and then 2 to the negative 3rd power was 1 over 8. And then 2 squared was 4, 2 to the negative 2 was 1 over 4. So that's going to be another concept we'll bring up. First off, let's talk about that 0 power. Anything raised to the 0 power is 1. Because when you divide a number by itself, you get 1, and that's what's happening in that table. So 7 to the 0 power is 1. Pretty simple. Here we have 5 times x to the 0 power. So we have two things happening. We have 5 being multiplied by x to the 0 power. So we have to be mindful of that. Here we know that anything to the 0 power, even a variable we don't know, because it doesn't matter what number we plug in there, it's going to be 1. So I can say that this is going to be 5 times 1. And then 5 times 1 is 5. Now on the bottom, we've got those negative big numbers, the negative bases that we talked about in our warm-up today. So we have negative 9 being raised to the 0 power. That is going to give us a positive 1 because that negative 9 is in the parentheses. We're raising that whole quantity to 0, which is 1. And then here we have the opposite of 9 to the 0 power, which is the opposite of positive 1, which is negative 1. We could also think about this as the opposite of 9 to the 0 power, putting that negative on the outside, and then 9 to the 0 power on the inside of the parenthesis. And then 9 to the 0 power would be 1, and then we'd still have that negative there. The last thing we'll talk about is negative power. So when the exponent, the little baby number, is negative. Let's first break it down by looking at an example of 4 to the 4th power divided by 4 to the 6th power. So we're going to expand that like we did in our investigation. And that's 4 times 4 times 4 times 4 on the top, 4 4s being multiplied together, and then 6 4s on the bottom. So now we're going to do the cancel or eliminate those 4s that make 1 pairs. And then what we have left is 1 on the top, and then 4 times 4 on the bottom. Now, I know 4 times 4 is the same thing as 4 squared. So that's going to be in my denominator, and then 1 on the top. So this is what we call exponential form when we leave an exponent in it. I could also go to simplified form and simplify it to 1 over 16 because I know 4 squared is 16. So now let's look at that exact same problem. We're not changing the problem at all. It's the same problem, but we're going to solve it using our power rule, our quotient rule, which tells us that we can subtract our powers. So we're going to do 4 to the 4th minus 6th power. So we're going to subtract those powers. So 4 minus 6 is negative 2, which means this simplifies to 4 to the negative 2nd power. Now, since this is the exact same problem, I know my answer is the exact same answer, which means 4 to the negative 2nd power is 1 over 4 squared, or 1 over 16, as you saw in the table that you filled out at the very beginning of this note video. So that's the reason why we were seeing that pattern in our table, because it really is using the same exponents, it's just moving it to the denominator. So anytime you have a negative exponent, to make it positive, you just flip it over, make it a fraction, and put that power in your denominator. So let's practice this a couple times with some problems. We have 5 to the negative second power. Now, the way to make that power positive is we just put that whole problem in the denominator and make that power positive. So it's going to be 1 over 5 squared. Now you can leave it in that exponential form. Sometimes problems will ask for an exponent in the problem. And if it asks for a simplified answer, we just simplify the power. 5 squared we know is 5 times 5, which is 25. So it would be 1 over 25. Here we have 8 to the negative third power. And again, we just make that positive by making it 1 over 8 to the third power. And I'm just going to leave that in exponential form. Now we've got some practice problems with operations. So we have 6 to the negative 15th power times 6 to the 8th power. I know that using my product rule, I can add those powers together. So that becomes 6 to the negative 15th plus 8 power. Well, negative 15 plus 8, that is negative 7, which means I know that this is 6 to the negative 7th power. But I want a positive exponent, not a negative exponent, so I'm going to flip that over into the denominator, and it's going to become 1 over 6 to the 7th power. Next, we have a division problem. So I know when I divide, I can subtract my exponents. So we have 5 to the 7 minus 11th. I want you to finish simplifying that problem and check your answer in Edpuzzle. Next, we have 4 to the third raised to the negative 4th power. So that's power to a power, which means we get to multiply our exponents. 3 times negative 4. Well, a positive times a negative is a negative. 3 times 4 is negative 12. So I know that that is 4 to the negative 12th power, which means to make that positive, we make it 1 over 4 to the 12th power. Go ahead and try this next problem on your own and see what you can do with it. Now, the very last thing is if you have a negative power in the denominator. So now, kind of opposite thinking, the negative is in the denominator. So in order to make it positive, we just flip where it is. We take it out of the denominator and we flip that around, and it becomes 4 to the positive third power over 1. We just flip it, make the exponent positive, and anything over 1 is just itself. So this is really just 4 to the third power. And same concept with if it's just a variable there, 1 over x to the negative 6th power would just become x to the positive 6th power. Go ahead and move into your practice.